Today we are going to begin Chapter 14, Ratios and Proportions. Several of the things that we're going to talk about are similar to what we did back in Chapter 5, which was our first Ratios and Rates chapter. However, we are going to be including some new things in this chapter, including slope and direct variation, and we are also going to be applying rates and proportions with positive and negative integers as well as rational numbers. Okay, some skills that you've learned before that are going to be very useful to you in this chapter are simplifying fractions. You can take a look at these examples. I'm not going to talk about it because this is a skill we've been doing for a long time. Identifying equivalent fractions. Remembering you just need to multiply both the numerator and denominator by the same number or a number equivalent to 1, such as 3/3 or 7/7. And then solving equations. Once again, none of these skills are anything new, but you will be applying them in this unit. Okay, our purpose today is to simply review ratios, rates, and unit rates from Chapter 5 so that we can apply these skills to new situations. Okay, meaning of a word rate. Here's an example. When you rent snorkel gear at the beach, you should pay attention to the rental rate. Okay, in this example, the rental rate is in dollars per hour. So since both of these rentals are per hour, it's very simple to look at the two and know which one is the better deal. Some other words that we talked about back in Chapter 5, ratio. Remember, it's a comparison of two quantities. Rate is a ratio of two quantities with different units, so such as miles per hour, price per pound, price per hour. There's lots of different examples that we could use, but the two things being compared are two completely different units. And then finally, remember, unit rate is when one of the numbers in the rate being compared is 1. Okay, let's take a look at our first example, and this is similar to what we've done before. There are 45 males and 60 females in a subway car. The car is traveling 2.5 miles in 5 minutes. So part A tells us to find the ratio of males to females. So the ratio was 45 to 60. I can divide both of those numbers by 15, and I end up with a reduced ratio of 3 to 4. So the ratio of males to females is 3 to 4. Part B says find the speed of the subway car. So this time we are talking about rates, not ratios, because we're comparing miles and minutes, not something that is of the same type of item. So if I take 5 minutes and I want to know how fast it's going in 1 minute, I divide both the 2.5 and the 5 by 5, and I get half a mile in 1 hour. So the speed is 5/10 miles per minute. And I think I said hour back here, but I meant to say minute. Okay, let's take a look at another example. This time, instead of a word problem with information, they give us a rate table. And you've made lots of rate tables over the past year. So the ratio table shows the cost for different amounts of artificial turf. Find the unit rate in dollars per square foot. Now notice, with all of these numbers, they are simply multiplying both numbers by the same number to increase or find a larger amount for the cost. So if I wanted to simplify it and find out what the cost is for 1 square foot, I have $100 for 25 square feet. If I wanted to find the cost for 1 square foot, I would divide both numbers by 25, and I get $4 per 1 foot. So the unit rate is $4 per square foot. Once again, nothing new. We've done this before. Okay, finally, we are going to talk about something new in this last example. It says at the top here, a complex fraction has at least one fraction in the numerator denominator, or both. You may need to simplify complex fractions when finding ratios. So in these ratios, it means at least one number is a fraction, and it could be both, or a decimal. Would be the same type of example. So it says the graph shows the speed of a subway car. Find the speed in miles per minute. Compare the speed to the speed of the subway car in example 1. So let's take a look at the first step here. It says choose and interpret a point on the line. So the point that they've chosen to use is 1/2, 1/4. Find the speed. So the distance traveled here indicates that the car is traveling 1/4 of a mile in half of a minute. Notice both of these numbers are fractions. So we have two fractions within our ratio. Now, I have mentioned multiple times this year that a fraction is simply a division problem. So when I have 1/4 over 1/2, the middle line right here, our fraction bar, simply means to divide. So I can take 1/4, divide it by 1/2. Remember the rules for division are keep it, change it, flip it. So when I multiply this out, I get 2/4. And 2/4 will reduce to 1/2. Okay, what that means is that the speed of the subway car is 1/2 mile per minute. Now, because 1/2 mile per minute is equal to 5/10 miles per minute in example 1, the speeds of the two subway cars are the same.